IPv6 addressing formats and conventions. The CCNA exam requires some fundamental skills in working with IPv4 addresses. You need to be able to take an address and mask and find the subnet ID. The biggest challenge with these tasks lies in the sheer size of the numbers. Thankfully, the math to find the subnet ID, often a challenge for IPv4, is easier for IPv6. Representing full and abbreviated IPv6 addresses. IPv6 uses a convenient hexadecimal hex format for addresses, with each set of 4 digits separated by a colon. IPv6 addresses also have a binary format as well. Converting from hex to binary is relatively easy. Just change each hex digit to the equivalent 4-bit value. Abbreviating and expanding IPv6 addresses. IPv6 also defines ways to abbreviate or shorten how you write or type an IPv6 address. The IPv6 address abbreviation rules let you shorten these numbers. Computers and routers typically use the shortest abbreviation, even if you type all 32 hex digits of the address. Abbreviating IPv6 addresses. 2 basic rules let you, or any computer, shorten or abbreviate an IPv6 address. Rule number 1, inside each quartet of 4 hex digits, remove the leading zeros. Rule number 2, find any string of 2 or more consecutive quartets of all hex zeros, and replace that set of quartets with a double colon. Note, you can use double colon only once in a single address. 2 instances exist where more than one quartet in a row has only a 0. Pick the longest such sequence, and replace it with double colon. Never remove trailing zeros in a quartet. Expanding abbreviated IPv6 addresses. To expand an IPv6 address back into its full unabbreviated 32-digit number, use 2 similar rules. The rules basically reverse the logic of the previous 2 rules. In each quartet, add leading zeros as needed until the quartet has 4 hex digits. If a double colon exists, count the quartets currently shown. Replace the double colon with multiple quartets of zeros so that 8 total quartets exist. The best way to get comfortable with these addresses and abbreviations is to do some yourself. Representing the prefix length of an address. IPv6 uses a mask concept, called the prefix length, similar to IPv4 subnet masks. Similar to the IPv4 prefix style mask, the IPv6 prefix length is written as a slash, followed by a decimal number. The prefix length defines how many bits of the IPv6 address define the IPv6 prefix, which is basically the same concept as the IPv4 subnet ID. The prefix length is a number of bits, value ranges from 0 through 128. Calculating the IPv6 prefix, subnet ID. With IPv4, you can take an IP address and the associated subnet mask, and calculate the subnet ID. With IPv6 subnetting, you can take an IPv6 address and the associated prefix length, and calculate the IPv6 equivalent of the subnet ID and IPv6 prefix. Like with different IPv4 subnet masks, some IPv6 prefix lengths make for an easy math problem to find the IPv6 prefix, while some prefix lengths make the math more difficult. Finding the IPv6 prefix. In IPv6, a prefix represents a group of IPv6 addresses. Each IPv6 prefix, or subnet if you prefer, has a number that represents the group. After you find the IPv6 prefix, you should also be ready to abbreviate the IPv6 prefix using the same rules you use to abbreviate IPv6 addresses. The abbreviation typically ends with 2 colons. You calculate the prefix for the subnet in which the address resides, by zeroing out the last 64 bits of the address. The /64 prefix length is by far the most common prefix length.